There is a particular kind of locomotive that almost nobody outside of railroad enthusiast circles has ever heard of. It was designed specifically for logging in mountain country. It looked, to the untrained eye, like somebody had built a normal steam locomotive and then started bolting extra machinery onto the side of it for no apparent reason. There were three main brands of it, all American, all designed in the 1880s and 1890s, all used heavily in the logging industries of the Appalachian Mountains, the Pacific Northwest, and the California redwoods for about 60 years. They were called geared locomotives because they drove their wheels through systems of gears instead of through the conventional connecting rods of a normal locomotive. The three brands were the Shay, the Climax, and the Heisler. Between them, they accounted for almost every locomotive ever sold to a mountain logging operation in North America. They cut through some of the most rugged timber country on the continent. They also killed a steady number of the men who ran them, in ways that the standard railroad industry never quite saw on its main lines. The first of the three was the Shay. Ephraim Shay was a logger and lumberman in Herring, Michigan, in the lower peninsula of the state, where the white pine forests of the Great Lakes region were being heavily cut in the 1870s and early 1880s. Shay ran his own small operation, and like most small operators, he had constant problems moving his logs from the cutting site to the river. He had built a short tramway of wooden rails out into the woods. The cars were pulled by horses, slowly with frequent breakdowns. The grades were steep. The curves were sharp. The horses couldn't handle the loads on the worst sections. Shay had a mechanical background, and around 1880 he began experimenting with a small steam locomotive of his own design. His goal was an engine that could pull heavy loads on the kind of rough, hastily built track that logging operations could afford to build. He wanted something that could run on grades up to 10 or 12%, take curves that no normal locomotive could navigate, and tolerate the kind of derailments and rough handling that ordinary railroad equipment couldn't survive. The design he came up with was unusual. He mounted the steam cylinders vertically on one side of the boiler. The cylinders drove a long crankshaft that ran the entire length of the locomotive on the same side. At each axle, the crankshaft turned a set of bevel gears, which transferred power to the wheels. The result was a locomotive that drove every wheel on the engine, including the wheels of the tender, through gears rather than through connecting rods. The arrangement gave high torque at low speeds, which was exactly what mountain logging needed. Shay's prototype ran for the first time around 1880. It worked. He patented the design in 1881. The Lima Locomotive Works of Lima, Ohio, took on production rights and began building Shay locomotives commercially that same year. The first commercial Shay was completed in March 1881 and shipped to a customer in Michigan. From that point on, the Shay became, by a substantial margin, the most popular geared locomotive ever built. Lima built approximately 2,700 Shay locomotives between 1881 and 1945. They ranged in size from small two-truck engines of around 15 tons to massive three-truck engines weighing over 150 tons. The largest Shays, built for the heavy logging operations of the Pacific Northwest in the 1920s, could pull loaded log trains weighing 700 or 800 tons upgrades that would have stopped any conventional locomotive of comparable size. They worked in every major timber region of North America, from the West Virginia coalfields where loggers and miners shared the same rail networks, to the redwood country of Northern California where the Shays climbed canyons too steep for any other equipment, to the mountains of Mexico and Central America where they hauled hardwood logs out of the highlands for export. The men who ran the Shays loved them and feared them in roughly equal measure. The locomotives were robust, mechanically simple, easy to repair, and forgiving of rough track. They were also slow, hot, smoky, and dangerous in specific ways that took a while to learn. The vertical cylinders on the right side of the boiler made the entire locomotive lean toward that side when the engine was working hard, and crews had to be careful about loading distribution on the cars behind. The gears running under the engine and tender were exposed in the early designs, and they could throw a piece of debris 100 feet if something jammed in them. The boilers, like all steam boilers of the period, could explode if the water level dropped too low or the safety valves failed. The most consistent killer on a Shay, however, was not the locomotive itself but the train it was pulling. Log trains in mountain country ran downhill loaded, often on grades of 5 or 6%, sometimes steeper. The locomotive's gears provided dynamic braking on descents in addition to the air brakes on the cars, but neither system was infallible. When a loaded log train got away on a steep grade, the result was usually a wreck of substantial proportions. The locomotive crew, if they could not stop the train, often jumped. Jumping from a runaway log train was almost always preferable to riding it down. The brakemen, who rode on top of the loaded cars in many operations, sometimes did not have the chance to jump. Estimates of how many men were killed running Shays in the timber industry vary widely. The locomotives were operated by hundreds of small companies in dozens of states over 6 decades, and no national accident statistics for industrial logging railroads were ever compiled in any comprehensive way. The state of West Virginia, which had a particularly intense logging railroad period from about 1890 to 1930, kept some records, and they suggest that perhaps 80 to 100 men were killed on Shay-powered operations in that state alone over those decades. Extrapolated nationwide, the total for the Shay over its entire service life was probably in the high hundreds, possibly over 1,000. Brakemen, firemen, engineers, switchmen, and various unlucky bystanders all contributed to the count. The second of the 3 iron beasts was the Climax. The Climax Manufacturing Company was based in Corry, Pennsylvania, and it produced its first geared locomotive in 1888, several years after the Shay had already established itself as the dominant brand. The Climax design used a different gear arrangement from the Shay. The cylinders were mounted at an angle on either side of the boiler, driving a transverse shaft beneath the locomotive that transmitted power through bevel gears to a longitudinal shaft, which in turn drove the wheels through more bevel gears. The result was a locomotive that, mechanically, was even more complex than a Shay, but offered some advantages in particular operating conditions. Climax locomotives ran with their gears better protected from the elements than Shay locomotives, which was important in the harsh weather of mountain logging operations. They were also slightly more powerful per ton of weight, on average, than Shay locomotives, and they could maintain higher speeds on level track. The downside was that the more complex gear arrangement was harder to maintain and harder to repair in the field, and Climax locomotives spent slightly more of their service lives in the shop than Shays did. The Climax Manufacturing Company built approximately 1,000 locomotives between 1888 and 1928. The company was smaller than Lima, and its production was concentrated in the Northeast, particularly in West Virginia, Pennsylvania, and New York. Climax locomotives were also exported in small numbers to South America, the Philippines, and South Africa. The company ran into financial difficulties during the Great Depression, restructured several times, and finally ceased manufacturing operations around 1928. Its surviving locomotives continued to operate for decades after the company itself was gone. The Climax had its own particular ways of killing crews. The complex gear system, when it failed, often failed catastrophically. There are several documented cases of Climax locomotives losing transmission gears at high speeds, with the broken pieces flying out of the gear case and into the cab or the surrounding equipment. The most spectacular of these incidents occurred in West Virginia in 1909, when a Climax locomotive working for the Greenbrier Cheat and Elk Railroad shed a main bevel gear under load. The gear, weighing several hundred pounds, was hurled out of the locomotive's gear housing and struck the fireman, who was standing in the cab feeding coal into the boiler. He was killed instantly. The engineer in the same cab was uninjured. The locomotive coasted to a stop on a grade. The crew of the next train down found the wreck about an hour later. The third of the three iron beasts was the Heisler. The Heisler Locomotive Works, based in Erie, Pennsylvania, produced geared locomotives starting in 1894, several years after both the Shay and the Climax had established themselves in the market. The Heisler design was the simplest of the three. Two cylinders were mounted at an angle in a V configuration beneath the locomotive, and they drove a single longitudinal shaft that ran along the center line of the engine. The shaft transmitted power directly to the inner axle of each truck, and the trucks were connected by side rods that distributed power to the outer axles. The result was a locomotive that was mechanically simpler than either the Shay or the Climax. It had fewer gears, fewer shafts, and fewer potential failure points. It was also on paper slightly more efficient than either of its competitors, with a higher percentage of the boiler's steam pressure converted to useful tractive effort. The Heisler design appealed to operations that valued reliability and ease of maintenance over sheer power. The Heisler Locomotive Works produced approximately 625 locomotives between 1894 and 1941. The company was the smallest of the three geared locomotive manufacturers, and its product was a niche choice within the larger market. Heisler locomotives worked primarily in the Pacific Northwest and in scattered operations across the South and Midwest. A few were exported to Canada and to operations in Mexico and South America. The Heisler had its own particular dangers. The V-cylinder arrangement made the locomotive ride lower than a Shay or Climax, which gave it better stability on rough track, but also meant that the cylinders themselves were vulnerable to damage from debris on the line. A Heisler that struck a log lying across the track could break a cylinder, with consequences ranging from a hot exhaust steam spray that could scald nearby crew to a more substantial failure that could disable the locomotive entirely. The single longitudinal drive shaft was also a vulnerability. If the shaft sheared, which happened occasionally under heavy loads, the locomotive lost all power at once, and a loaded log train on a downgrade had no dynamic braking to slow it down. The air brakes in those situations were often not enough. The total production of the three geared locomotive manufacturers combined was approximately 4,300 locomotives. They worked in various combinations every major American timber region from the late 19th century through the middle of the 20th. They cut through forests in West Virginia, Pennsylvania, New York, Michigan, Wisconsin, Minnesota, Oregon, Washington, California, Idaho, Montana, and a dozen other states. They hauled out the white pine of the Great Lakes, the hardwoods of the Appalachians, the Douglas fir of the Pacific Northwest, and the redwoods of California. Without them, none of these timber harvests could have happened on the scale and at the speed at which they actually did happen. The decline of the geared locomotive came in the 1920s and 1930s with the rise of truck logging. Heavy trucks on improved roads could move logs more flexibly than any railroad system could. They didn't need to follow a fixed line of track. They could work a small cut and then move on, without the cost of building and tearing down a temporary railroad. The economics turned against the geared locomotive starting around 1925, and by 1940 the new orders for geared locomotives had dropped to a trickle. Lima built its last Shay in 1945. Climax had ceased production in 1928. Heisler built its last locomotive in 1941. The era of the geared logging locomotive was effectively over by the end of World War II. The existing locomotives, however, continued to work. Operations that had already paid for their geared engines kept running them for as long as they made economic sense. The last commercial use of a Shay in regular service is generally given as 1960 by the West Side Lumber Company in California. Climax locomotives ran into the 1950s in West Virginia. Heisler locomotives also ran into the 1950s. After commercial service ended, the surviving locomotives were either scrapped, donated to museums, or, in a few cases, purchased for use on tourist railroads. The survivors today are scattered across North America. Probably 40 to 50 Shay locomotives still exist, with around 20 in operating condition. The Cass Scenic Railroad State Park in West Virginia is the largest single collection of operating geared locomotives, with several Shays and a handful of Climax and Heisler engines running through what is now a state park surrounding the old Moa Lumber Company operation. The Roaring Camp and Big Trees Railroad in California operates 2 Shays through Redwood Country. The Mount Rainier Scenic Railroad and the Black Hills Central Railroad both operate geared locomotives. Static displays exist at dozens of museums, including the California State Railroad Museum, the B&O Railroad Museum in Baltimore, and the Mid-Continent Railway Museum in Wisconsin. The Climax and Heisler are rarer than the Shay, simply because fewer of them were built and fewer survived the scrap drives of the World Wars. The Climax Locomotive Works has, depending on how you count, somewhere between 15 and 20 surviving examples, with about 5 in operating condition. The Heisler has perhaps a dozen survivors, with 2 or 3 operable. Several Heisler locomotives are in long-term restoration projects at various railway preservation groups. The men who ran the geared locomotives are nearly all gone. The youngest of the working crews from the last regular commercial operations in the late 1950s would now be in their late 80s or 90s, and very few are still living. Oral history collections at the West Virginia Department of Archives and History, the University of Oregon, the California State Railroad Museum, and several other institutions preserve recordings of crews from earlier decades. These recordings, taken mostly in the 1970s and 1980s, contain first-hand accounts of working the locomotives in conditions that the modern visitor to a tourist railroad would have difficulty imagining: 20-hour days, below-zero temperatures, track that derailed regularly, wrecks that killed 3 or 4 men at a time, and that the surviving crews cleared by hand because there was no way to bring in heavier equipment. The forests that the geared locomotives worked are mostly different forests now. The old growth that was cut from the 1880s through the 1930s is gone. The second growth forest that grew up in its place has been cut in most areas at least once, and sometimes more than once. The mountains of West Virginia and Pennsylvania, which were almost completely deforested by 1920, have grown back to a degree that surprises visitors who know the history. The Pacific Northwest, which was cut over more slowly because of its larger original timber resource, retains a higher proportion of old growth than the East, but has still lost most of its original forest. The Redwood Country of California retains a few % of its original old growth and has been cut over many times in the unprotected areas. The geared locomotives did what they were built to do. They cleared the mountains of timber, and they killed a number of the men who ran them, and then their world ended and they were either melted down or parked on display. The 3 companies that built them, Lima Locomotive Works and Climax Manufacturing and Heisler Locomotive Works, are all long since out of business. Lima continued to build conventional steam locomotives until 1949, when it merged with Hamilton Diesel to form Lima Hamilton, and then with Baldwin to form Baldwin Lima Hamilton, which itself ceased locomotive production in 1956. Climax and Heisler had both shut down well before that. The American geared locomotive industry, as a going concern, was finished by 1945. Its surviving products, the locomotives still running on tourist lines in West Virginia and California and Washington, are the last working representatives of a technology that defined an entire era of industrial American timber production, and that has otherwise almost entirely disappeared from the public memory of the country it helped to build. A few specific operations are worth describing in more detail because they illustrate the working conditions and the accident patterns of the geared locomotive era. The Cass Scenic Railroad, now a tourist line in West Virginia, runs over a former logging railroad that was operated by the Moa Lumber Company and its predecessors from about 1901 to 1960. The line climbs from Cass at 2,452 feet elevation to Bald Knob at 4,842 feet, an elevation gain of about 2,400 feet over about 11 miles of track, with grades reaching 11% in places. This is steep track even by geared locomotive standards. The line operated continuously for nearly 60 years, hauling spruce, hemlock, and hardwood from the Cheat Mountain country to the mill at Cass. At peak production in the 1920s, the operation employed about 2,000 men, including the railroad crews, the woods crews, and the mill workers at Cass. The accidents on the Cass Railroad are documented in considerable detail because the state of West Virginia preserved many of the company records after the operation closed. Between 1902 and 1960, the railroad logged at least 15 fatal accidents directly involving the locomotives or rolling stock. The actual total was probably higher because the early records from the first decade of operation are incomplete. Causes included derailments on the steep grades, runaway log trains that crashed at the bottom of the mountain, men crushed between cars during coupling operations, and at least 3 boiler explosions on the locomotives. The worst single incident at Cass was a 1920 wreck in which a runaway train of log cars on a switchback near the summit derailed, killing 4 crew members and destroying 2 cars of logs. The locomotive involved, a Shay, was recovered from the wreckage and rebuilt at the Limmer shops, and it returned to service the following year. The Tionesta Valley Railway in Pennsylvania operated from 1887 to 1929, primarily hauling hemlock from the Allegheny National Forest area to the bark mills and the lumber mills at Sheffield. It used Climax locomotives almost exclusively, having ordered its first machines directly from the Climax works in nearby Corrie. The railroad was about 70 miles long at its peak, with numerous branches into specific cutting areas. Its accident record was probably worse than the Cass line, although the documentation is sketchier. A 1907 derailment killed 3 men. A 1913 boiler explosion on a Climax killed 2 more. A 1922 runaway killed the engineer, fireman, and brakeman of the lead locomotive when the train piled up at the bottom of the grade. After the timber was cut out, the railroad was abandoned and the rails were taken up for scrap during the Great Depression. Today, the right-of-way is mostly walking trails through the regrown forest, and few visitors realize they are walking over an industrial route that once moved millions of board feet of hemlock a year and that killed a steady stream of men in the process. The Redwood Country operations used Shay locomotives almost exclusively because the gauges of curvature and the steepness of the grades in the coastal mountains made them the only practical choice. The Pacific Lumber Company operated a complex network of woods railroads out of Scotia, California, from 1885 until the conversion to truck logging in the late 1940s. At the peak in the 1920s, the Pacific Lumber Rail System included over 100 miles of track and operated more than a dozen Shay locomotives, plus various rod engines for the main line hauling on level ground. The accidents were frequent. A 1916 wreck on the line up Larrabee Creek killed 2 crew members when a Shay rolled off a temporary bridge. A 1923 collision between 2 log trains in fog killed 3 more. The runaway problem was particularly severe in the Redwood Country because the loads were so heavy. A single redwood log on a flat car might weigh 50 or 60 tons. A train of 10 such cars represented hundreds of tons rolling on a grade that the locomotive's brakes could only barely control. When a train got away from its brakes, the result was usually total destruction, and the men on the locomotive almost never survived. The Casper Lumber Company operated a smaller railroad north of Fort Bragg, California, from the 1880s into the 1940s. The line was famous in the railfan community because it operated some unusual locomotives, including a Heisler that was modified for the company's specific track conditions. The Casper operation, more than most, has been documented by amateur historians and railroad photographers in the years since its closing, and the photographic record of the railroad is considerable. Several of the company's locomotives survive, including one Shay, that is on static display at the California State Railroad Museum in Sacramento, and a smaller industrial locomotive that is preserved at the Mendocino Coast Model Railroad and Historical Society in Fort Bragg. The Mount Rainier Scenic Railroad in Washington State operates today over part of the former Tacoma Eastern Railroad route. The original line carried logs from the Cascade foothills to the mills at Tacoma and Seattle. It was, in its time, one of the larger logging railroads in the Pacific Northwest, with extensive Shay and Climax operations. The accident records from the line include a famous 1907 wreck in which a Shay went off a curve at a place called Tatoosh and rolled down a steep slope, killing the engineer and fireman and destroying the locomotive. The locomotive was eventually salvaged and rebuilt, and it returned to service in 1908. It worked another 25 years before being scrapped in 1933. The mechanics of the Runaway accident, which was the most frequent cause of fatal incidents on the geared logging lines, deserve a fuller description because they illustrate something about the working environment that is hard to convey otherwise. A loaded log train running downgrade was kept under control by a combination of locomotive brakes, hand brakes on the individual cars, and, in the worst cases, by a brakeman riding the top of the cars and setting the hand brakes as needed. The locomotive brakes alone were never sufficient to hold a heavy log train on a grade exceeding about 4 or 5%. The hand brakes, set on each car, supplemented the locomotive brakes. On the steepest sections, the brakeman had to ride the tops of the cars in motion, jumping from car to car and tightening the brake wheels, in order to keep the train from accelerating beyond what the locomotive could hold. This was a dangerous practice. A brakeman who slipped, or who was knocked off by a low overhead branch, or who simply lost his grip on a wet brake wheel, was likely to fall under the wheels of the train. The records include numerous deaths of brakemen this way. When the hand brakes alone were insufficient and the train began to overrun the locomotive's ability to hold it, the engineer had a few last options. He could try to apply the locomotive's emergency brake, which might or might not work, depending on the steam pressure and the condition of the brake shoes. He could try to deliberately derail the train at a safe spot by setting a switch to a siding or by aiming for a stretch of soft ground. He could jump off the locomotive, which usually meant either death or serious injury, but which had occasionally saved a man's life. Most commonly, when a train ran away, the crew rode it to the bottom and hoped for the best. The outcome was almost always bad. A particular incident from the West Virginia operations illustrates how the runaways typically ended. In 1934, on a logging railroad in Pocahontas County, a loaded log train running downgrade on a 4-mile descent lost its brakes near the top of the grade. The engineer reported afterward, when he was being interviewed in the hospital, that he had felt the brakes fade about a mile into the descent, that he had set the emergency, that he had blown the whistle to signal the brakemen to set the handbrakes, and that he had then realized the train was already moving too fast for the brakemen to do anything. He instructed the firemen to jump, which the firemen did, suffering a broken leg and various lacerations, but surviving. The engineer rode the locomotive to the bottom of the grade, where the train was running at an estimated 60 miles per hour, which was probably twice the safe speed for that section of track even when empty. The locomotive went off a curve, rolled 3 times, and ended up upside down at the bottom of the embankment. The engineer was thrown clear in the rolling and survived with serious injuries. The 4 log cars behind the locomotive piled up on top of the wreckage, destroying the locomotive completely and scattering logs over a quarter of a mile of track. No one else was on the train, which was a piece of luck because the brakeman had been planning to ride this particular trip and had been pulled off at the last minute to handle a different task at the loading area. If they had been on the train, they would almost certainly have died. Stories like this one repeated themselves with variations across the entire geographic range of geared locomotive operations from the 1880s through the 1940s. The pattern is sufficiently consistent that any thorough study of the industry encounters the same kinds of incidents over and over. Different states, different companies, different terrain, different decades, but the same basic accident: heavy load, steep grade, failing brakes, terminal pile-up at the bottom. The geared locomotive was particularly suited to working steep grades, which was why it was preferred over conventional rod engines in logging service. The same characteristics that made it valuable also made it dangerous, because the operations it enabled put trains on grades and curves that no sensible railroad would have used for general freight service. The work culture of the geared locomotive crews had its own characteristics. The engineers were typically older men, often in their 40s or 50s, who had worked their way up through the ranks over many years. The firemen were younger, often in their 20s or 30s, and the position was a stepping stone to engineer. The brakemen were the youngest, often teenagers or men in their early 20s, and the position was the most physically demanding and dangerous job on the train. A typical crew might consist of 3 to 5 men, depending on the size and configuration of the train. They worked in close quarters, lived in the same camps, and developed strong personal bonds with each other. The death of a crew member was a serious blow to the surviving crew, and the men who outlived their colleagues often carried significant survivors' guilt for the rest of their working lives. The oral history recordings from the 1970s and 1980s contain numerous interviews in which former crew members, by then in their 70s or 80s, describe accidents from decades earlier in detail that suggests the memories had remained vivid throughout the intervening years. You can ride one of them, if you want, at any of the surviving tourist railroads. The experience is partial and removed in the way that any tourist ride is partial and removed from the real working conditions of the technology it represents. The locomotives go slowly, the track is good, there are no log loads behind, the brakemen do not ride the tops of cars, the danger of a runaway on a steep grade is essentially absent. But the basic experience of being pulled along a forest track behind a steam engine that drives its wheels through gears with the cylinders chuffing and the gears whining is still there. The smell of the coal smoke is still there. The sound of the whistle echoing off the mountains is still there. For an hour at a time in a few specific places, you can listen to what an American forest sounded like to the men who were cutting it down at the rate of millions of acres a year 100 years ago.